Hey everyone, welcome back to the channel where the universe sends us anxiety and we reply with curiosity and bad jokes. First off, massive thanks to all of you, really, every single every comment that starts with this gave me chills or bro, are we in a simulation, fuels this cosmic madness. You're the reason we stay up late reading research papers and drinking coffee that could probably strip paint. It's been insane watching this channel grow, seeing people from all over the planet united by one thing, our shared confusion about what the cosmos is doing. Thank you for being part of it. You've made our weird little project into a digital spaceship of wonder, sarcasm, and science. Now let's hit the thrusters, because today we're asking one question that kept Harvard astrophysicists up at night. What if 3I slash Atlas, the mysterious green interstellar comet, didn't just fly by? What if it came straight for us? Could humanity survive a direct hit? Spoiler alert, no, not even close. But let's take it from the beginning. It all starts with an object quietly sliding through our solar system, not from within it, but from outside. 3I slash Atlas is only the third confirmed interstellar visitor humanity has ever detected. And like all uninvited guests, it immediately broke the rules. It glows bright green, but lacks the molecules that should make it glow. Its orbit is impossibly stable, too stable, and it's moving faster than anything naturally bound to our sun. Imagine something made billions of years ago, drifting between stars for eons, then suddenly deciding to swing by Mars and leave scientists collectively saying, "What the hell?" The first clue came from the Mars Reconnaissance Orbiter. Instead of a faint fuzzy blob, cameras picked up a razor thin streak, a perfect line, moving exactly as predictions said it would. But something was missing. Most comets wobble under gas jets, like self propelled sprinklers. 3I slash Atlas didn't. No jitter, no kick, no subtle curves. Pure mechanical perfection. It's like a bowling ball in vacuum, one researcher said, except the bowling ball glows neon green. So what gives? The glow. Normally, green comets shine thanks to a chemical called diatomic carbon, C2 molecules excited by sunlight. But Harvard's spectrographic readings showed no trace of C2. Instead, strong emissions of nickel, weirdly no iron, and 3 times the expected carbon dioxide levels. Imagine something chemically built upside down, cosmic chemistry written in reverse. The more we study it, one chemist joked, the less it evades the universe. A student described it as a comet that read the periodic table and decided to freestyle. Meanwhile, amateur astronomers recorded the object's steady movement. Some thought their gear was broken because 3I slash Atlas refused to drift when modeled under solar pressure. Think of it this way, most comets are like kites. Solar radiation pushes them slightly. But this thing acts like a 10-ton truck crushing headwind. That consistency triggered sleepless nights at Harvard's dynamics lab. They concluded the mass must be orders of magnitude higher than expected for interstellar bodies, or that some external stabilizing force was involved. External meaning, well, deliberate. And here's where things get eerie. When Harvard traced the trajectory backward through space, it appeared to align, within error margins, with the coordinates of the famous 1977 WOW signal. That narrowband radio burst at exactly the hydrogen frequency, the hello frequency scientists would expect from an extraterrestrial transmission. Coincidence? Maybe. Cosmic irony? Possibly. But then again, the probability calculations wavered around 0.6%. It's small enough to laugh at, said Abby Loeb, but not small enough to sleep well. Now, Harvard doesn't do panic. They do math, which is far worse, because math doesn't care how terrifying the answer is. So let's game this out. At 60 kilometers per second, that's roughly 134,000 miles per hour. If 3I slash Atlas were to collide with Earth, it would unleash energy equivalent to 100 million megatons of TNT. That's all the nuclear warheads on Earth multiplied by a few thousand, going off at once. Oceans would evaporate. The atmosphere would ignite. The very concept of Monday would cease to exist. Harvard's internal report called it a terminal level planetary event. We just call it Tuesday in space. But before booking your apocalypse bunker, The collision odds are nearly zero. Atlas won't even come close to Earth this pass unless physics stops working, which lately doesn't feel entirely off the table. Still, that hasn't stopped people from praying, panicking, or writing songs called Green Goodbye. Because humans love drama more than data. Let's zoom into the chemistry again. Nickel without iron. Nickel glowing in low temperatures where it shouldn't even vaporize. How? One bold theory, brace yourself, is that 3I slash Atlas might not be solid at all. It could be porous metal foam, a lattice like structure designed for mass efficiency during interstellar travel. Yeah, that theory didn't come from a random Reddit post. It came from a peer reviewed preprint that Avi Loeb students refused to sign their names to. But think about it, if something were built to survive deep space travel, millions of years of radiation, micrometeoroid impacts, and cosmic cold, porous nickel alloy would work beautifully. Light enough to accelerate, strong enough to survive, reflective enough to fool telescopes. Too coincidental? Not for YouTube. Now picture this. As it drifted close to Mars, some orbiters caught unexplained radio noise bursts timed precisely with the comet's perihelion. Those frequencies matched harmonic multiples of hydrogen's spectral line. Again, probably natural interactions between ions, but if you were trying to get attention in a cosmic neighborhood, that's exactly the frequency you'd pick. Space Force noticed. They didn't say it publicly, but two tracking satellites quietly pivoted to deep space lock mode for over 18 hours that week. Calibration tests, the press release said. Sure, calibration. When Harvard released their impact models, they didn't sugarcoat. Global sterilization event, loss of stratospheric cohesion, post impact infrared bloom lasting 300 days. In short, no survival. The heat pulse alone would evaporate half the ocean before shockwaves even reached the tropopause. Every nuclear exchange ever simulated looks like a candle next to this. Their closing remark reads like a sci fi horror script. Human civilization ceases at moment t plus 42 seconds. And then, because scientists are weirdly poetic, they added, if destruction comes from the stars, it will remind us that our beginnings came from them too. Imagine ending your academic paper with a metaphysical mic drop. But it's not just fatalism, it's humility. Because whether 3I slash Atlas is natural or not, its sheer existence shatters the illusion of control. We are small. We've always been small. But somehow, even knowing that, we still aim telescopes and ask questions instead of hiding. That's the human miracle. Still, weird patterns continue. During solar flare events, Atlas's green glow deepens dramatically. The response lags by about 3 minutes, too fast for normal chemical excitation. One theory is that its shell contains photoreactive crystals amplifying solar particles. Another is that it's responding to energy, that the glow is the comet's way of saying, I see you. Think of cosmic photosynthesis, but alien. Some observers joked it's like watching a space jellyfish pulsating with sunlight. A terrifying, borderline majestic jellyfish with the power to vaporize continents. Meanwhile, in private, observatories are trading encrypted data packets about spectral coherence, measured regularity in its emissions. One phrase appears again and again in leaked documents: non random modulation. In space speak, that means this light might be encoding something. Harvard refuses to comment. SETI says unlikely. But deep inside, everyone's wondering, are we watching an artifact announcing itself non-verbally, using light as a language we can't yet decode? If the answer is yes, everything about how we view the universe changes overnight. If the answer is no, well, at least we've discovered a chemical that physics forgot to tell us about. Win-win. And yet, Atlas keeps gliding silent, straight, indifferent. When Mars lost visual contact due to solar conjunction, data went quiet. Everyone held their breath, waiting for reappearance. When it emerged weeks later, the glow was brighter than ever. Same trajectory, same arrogance. One researcher sighed, it's like this thing wants attention but not conversation. Harvard's next paper, simply titled Persistence Without Deviation, was a mix of admiration and dread. Persistence, indeed. So, could we survive a direct hit? No. Could we deflect it? Also, no. Could we at least make good memes before the apocalypse? Absolutely. And that's the silver lining here in facing our doom. Humanity does what it always does, laughs, theorizes, and live streams the end. Space may kill us someday, but it'll never beat our humor. Still, what if it's not coming to destroy, but to teach? Maybe it's a messenger, a probe carrying chemical data across the void, showing us a spectrum we've never seen. Maybe it's a mirror of our own arrogance, a reminder that we still understand only fragments of universal law. Or maybe, just maybe, it really is alive in its own alien way. When Harvard modeled its light flicker frequencies, they found mathematical ratios eerily close to prime intervals. Coincidence? Perhaps. Or maybe nature itself speaks in primes, and we're just now learning her dialect. So here we are, watching a cosmic miracle with one part fear, two parts fascination. Three Eye slash Atlas might never touch us physically, but it already hit us mentally. It cracked open the door to deeper questions. What if other civilizations send messages not as signals, but as travelers? What if light, color, and chemistry are their language? Maybe the question Harvard asked, could we survive a direct hit, isn't about physics at all. Maybe it's about meaning. Could we, as a species, survive the truth of not being alone? Could our egos, economies, and beliefs handle that? Could humanity survive contact, not collision? Because the real danger isn't that 3i slash Atlas might hit us. It's that it's hitting our worldview, dismantling the illusion that we've figured it all out. And that's the impact from which no civilization truly recovers. Whatever happens, this glowing emerald intruder gave us a gift, wonder mixed with existential dread. It made astrophysicists giggle nervously, philosophers ask better questions, and conspiracy theorists have the week of their lives. It reminded everyone, from Harvard to your living room, that the universe never plays by our rules. It writes its own in light, speed, and silence. So don't look away. Don't panic either. Just look up, breathe, and remember every green shimmer in the night sky is the universe whispering, adapt or vanish. And we, stubborn as ever, whisper back, not today. But here's where it gets creepy. When Harvard's astrophysics lab modeled its inbound path backward, guess where it came from? The same region of space where the famous 1977 WOW signal originated, that one time, unexplained radio burst so pure and so narrowband that it matched no known natural process. That signal was humanity's closest brush with a possible alien thing. Now, 4 decades later, something is flying in from the same coordinates, glowing an unnatural green and ignoring basic physics. Coincidence? Maybe. But it's the kind of coincidence that makes scientists quietly close their laptops and check the existential Dread Wiki. Now, before you call this alien nonsense, NASA refuses to call it artificial. But here's what's weird. They also haven't published all their data. Several Mars orbiters captured Atlas during its flyby. Perseverance even caught 9 minutes of faint streak movements, and then NASA went silent. No raw frames. No open telemetry. People who specialize in processing open data noticed certain timestamps missing. It's likely a technical delay, or, as conspiracy Twitter insists, the space agencies had a group meeting and collectively decided to ghost us. Harvard's own team received delayed telemetry, forcing their simulations to rely on incomplete real time tracking. But even from limited data, the object's stability screamed artificial. Okay, let's breathe. It's probably just chemistry being weird again, right? Not so fast. The thing is releasing nickel, but no iron. That's like seeing ketchup without tomatoes. Nickel and iron are cosmic twins. They're forged together in dying stars. Finding nickel without iron means this object might have formed under entirely alien stellar conditions. Or, and here's the sci fi Kool-Aid moment, it was forged differently. Some kind of structured process, possibly artificial metallurgy. Now, joke all you like about Harvard's eggheads, but even they sprinkled their official report with phrases like non natural compositional ratios and anomalous chromatic persistence. In simpler terms, it glows wrong and it doesn't care that we noticed. Meanwhile, some independent physicists calculated that if its mass and reflectivity are correct, it shouldn't even be visible at this distance. Harvard tried to explain it by calling it an energy storing compound with delayed photonic release. Translation: it absorbs sunlight and spits it back oddly timed, kind of like a cosmic glow stick that refuses to go out. While most of Earth shrugged, military branches didn't. Space Force quietly repositioned two deep space radars, officially for instrument calibration, unofficially for tracking Atlas. And yes, classified documents exist mentioning photon interference from object at L3. That phrase alone sounds like someone in uniform sweating over something unnatural. A few theoretical physicists proposed it's emitting coherent light, laser like signals embedded in the green emission spectrum. Harvard stopped short of confirming that. But if coherence is verified, that's not chemistry. That's communication. So here's the question nobody can answer: what if Atlas isn't just passing by? Every comet we've ever observed dissipates when heated. Atlas, instead, brightens, sharpens, and increases structural integrity the closer it gets to sunlight. It's like it charges. When it grazed Mars, the green intensity spiked 28% during one solar flare, exactly when NASA's tracking arrays overloaded with radio noise. That's a lot of coincidences. But beyond the science fiction vibes, here's the grim math. Harvard found that if Earth were to be struck by even a 1 kilometer fragment of 3I/Atlas traveling at 60 kilometers per second, the energy overlap would raise global temperatures by 30 degrees Celsius near instantly. That's not living in scorched ruins. That's turning the entire sky into an oven. Humanity gone in seconds. The impact's shockwave would exceed escape velocity, literally blasting part of our atmosphere into space. And the shock cone? It would circle the planet twice before dying out. Harvard called such a collision a terminal climate reset, the polite way of saying game over. And yet, despite the drama, none of this has stopped people from making memes about it. My favorite? Comet Atlas, humanity's green notification that your subscription to existence is expiring soon. Dark humor aside, our species is hilarious when terrified. Still, the most fascinating part isn't the destruction potential. It's that 3I/Atlas seems to defy randomness. It entered our solar system exactly along the planetary plane, the same plane where all major planets orbit, minimizing observation angles, maximizing solar fuel intake. That's the flight plan of something with intent, not just chance. Harvard's data even shows minor micro-oscillations in its brightness occurring at consistent intervals, pulses separated by exactly 142 seconds. That number, 142, might sound random, but multiply that by the hydrogen line frequency in megahertz, and you get precisely the range of the original WOW signal. Coincidence again? Or someone's clever way of saying, we remember you? Now, of course, science requires skepticism. Harvard refused to label this intelligently controlled. But several peer reviewers asked whether those pulses could result from internal rotation patterns, maybe reflective facets, perhaps uneven albedo. The scientists said possible, but not confirmed. Some SETI argued we should beam a controlled reply toward it. Harvard said under no circumstances. They literally wrote, humanity should observe, not announce. That says a lot when the people known for curiosity are suddenly like, let's not make eye contact with the glowing space rock. So let's tie this back to the big question. Could we survive a direct hit? No, categorically not. But let's play devil's advocate. Suppose an impact was inevitable. Could we deflect it? NASA's DART mission proved we can nudge asteroids, but only tiny ones, near Earth, and moving at comfortable lethargic speeds. 3I/Atlas is nearly 10,000 times faster. The best we could do is apologize politely. Nukes? Useless. They'd barely tickle its momentum. Harvard concluded we'd need a gravitational tug 400,000 times stronger than DART's kinetic transfer. Translation: that technology doesn't exist. Not even in sci-fi. But here's what's oddly comforting. The chances of an impact are basically zero. Not 0-0, but you'd have better odds of your toaster inventing time travel. Still, the idea forces a bigger reflection. This glowing interstellar intruder, this impossibly consistent, alien-sounding, physicist annoying bruise on the night sky, reminds us how fragile our existence really is. It doesn't matter how many telescopes we build or theories we publish. One good rock and we're gone. That's humbling in the most cosmic way possible. Yet this isn't a story about fear. It's a story about curiosity. Humanity staring at the sky and saying, I want to know. It's the same stubborn instinct that made someone in the 1600s point a homemade lens upward and start modern astronomy. Today, we're using billion-dollar telescopes and AI processing pipelines, but the core emotion is identical: wonder. Even Harvard's darkest conclusions are built on that flame of curiosity, that refusal to look away. So, if 3I slash Atlas glows brighter, dances closer, or streaks across the sky in ways science can't quite explain, here's my advice: look up. Not to panic, not to pray for survival, but to witness the universe doing what it's always done, surprising us. It might destroy us someday, sure, but honestly, what a scenic way to go. Humanity's final moment lit by a green interstellar flame, it's poetic. And if it's really a messenger, then at least someone, somewhere out there, cared enough to say hello the hard way.